Welcome. Today we are diving into Azure Blob Storage with a specific focus on how to create, configure, and manage containers securely and efficiently. Let's get started. Welcome everyone. Today we explore Azure Blob Storage, focusing heavily on creating and configuring containers. Blob Storage is Microsoft's AI-ready object storage solution, highly optimized for storing massive amounts of unstructured data such as text, documents, images, and videos. To store data, Azure uses a specific hierarchy. It starts with an Azure storage account, which holds containers, which in turn hold your blobs. Think of a container as a logical folder in a file system, organizing your unstructured objects. It is a strict rule in Azure that a blob cannot exist by itself. It must be stored inside a container resource. As your environment scales, a single storage account can host an unlimited number of containers, and each of those containers can hold an unlimited number of blobs, providing massive scalability for your applications. Looking at this diagram, we see the fundamental hierarchy of Azure Blob Storage. At the very top is the Azure Storage Account, which acts as the parent management resource. Branching down, we have our containers, acting as logical folders to separate our workloads. Inside these containers reside the actual blobs, representing our unstructured data. As you can see, Container 1 holds media files like images and videos, while Container 2 is used for logs and backups. This structure keeps massive datasets organized and allows us to apply different security policies to different containers. Creating a container is the absolute first step you must take before you can upload any data to Blob Storage. You can easily create a container through the Azure portal by navigating to your storage account, selecting Containers in the Data Storage section, and clicking the Add Container button. However, you cannot just use any name. You must follow strict naming conventions enforced by Azure. First, the container name must be entirely unique within that specific Azure storage account. Furthermore, the name must be between 3 and 63 characters long, and it can only contain lowercase letters, numbers, and hyphens. Finally, it must always begin with a lowercase letter or a number. Adhering to these strict constraints ensures your container is successfully provisioned and uniquely identifiable within your storage namespace. This flowchart traces the validation process during container creation. You start the creation process in the Azure portal. The system immediately checks your input against the naming rules. If your chosen name contains uppercase letters, special characters, or is too short, it flows to the red validation failed path. If it strictly follows the rules using only lowercase letters, numbers, and hyphens, and is the correct length, it passes validation, successfully flowing to the green path where your new container is provisioned. Security is paramount, and configuring the correct public access level for your container is a critical administrative task. When you create a container, the default access level is always private. This securely prohibits anonymous access entirely, making data visible only to authorized users. If you are serving public content, like images for a public website, you might choose the blob access level, which allows anonymous read access for individual blobs if the user knows the exact URL. Alternatively, the container access level allows anonymous users to read blobs and actually list the contents of the entire container. As a deep dive, it's vital to know that these container-level settings are subordinate to the storage account. If the storage account's Allow Blob Anonymous Access setting is disabled, all containers remain strictly private regardless of their individual settings. Microsoft highly recommends keeping anonymous access disabled unless specifically required. Let's visualize how access evaluation works for anonymous requests. The request first hits the account level setting. If Allow Blob Anonymous Access is disabled, the request is instantly denied, shown by the red box. If enabled at the account level, the system then checks the specific container access level. If the container is set to private, access is still denied. Only if the container is explicitly set to the blob or container level will the anonymous request be allowed through to read the data. This demonstrates why account-level governance is so powerful. Once your container is securely configured, you must decide what type of blob to upload into it. Azure offers 3 types: block, append, and page blobs. Block blobs are the default. They consist of blocks of data assembled together, making them ideal for storing general-purpose text and binary data, like documents, images, and streaming videos. Append blobs are also made of blocks, but are optimized strictly for append operations. This makes them perfect for logging scenarios where application data is continuously added to the end of a file. Finally, page blobs are highly efficient for random read and write operations. They can be up to 8 terabytes in size and are primarily used as the underlying storage for Azure Virtual Machine Operating System and data disks. Choosing the right type ensures optimal performance, because once a blob is created as a specific type, you cannot change it later. This diagram categorizes the 3 blob types you can store in your containers. When uploading data, you select a path. The block blob path is best for your standard files and media. The append blob path is specialized for continuous logging operations without modifying existing data blocks. The page blob path is strictly utilized for virtual hard disks and scenarios requiring random read/write access. Remember, the choice made at the yellow diamond is permanent for that specific file. To optimize costs, containers leverage storage access tiers. Azure Blob Storage supports hot, cool, cold, and archive tiers. The hot tier is designed for actively processed data, featuring the highest storage costs, but the lowest data access costs. If you have data that is infrequently accessed, you can move it to the cool tier, intended for data stored for at least 30 days, or the cold tier for data stored at least 90 days. These tiers offer significantly lower storage costs. The archive tier is for long-term retention and offers the absolute lowest storage cost. However, archive data is completely offline. To read it, you must rehydrate it to an online tier, which can take up to 15 hours. By default, blobs inherit the access tier set at the storage account level, but you can explicitly override this by setting a different tier on an individual blob inside your container. This visual spectrum maps the access tiers against their cost and availability trade-offs. On the top, the hot tier represents high availability and higher storage costs, ideal for active workloads. Moving to the middle, cool and cold tiers decrease your storage costs while slightly increasing access costs. At the bottom, the archive tier offers the cheapest storage possible, but notice it is marked offline. It requires hours of rehydration time before that data is accessible to your applications. This structure helps you align your data's lifecycle with the most cost-effective tier. Managing access tiers manually for thousands of blobs inside a container is highly inefficient. This is why we configure Blob Lifecycle Management. This feature provides a rich, rule-based policy engine to automatically transition blobs to cooler storage tiers or delete them at the end of their useful lifecycle. You define standard if-then block conditions. For example, if a blob hasn't been modified in 30 days, then automatically move it to the cool tier. You can apply these rules to the entire storage account or use filter sets to be highly specific. By specifying a container name or a blob prefix match, you strictly target only certain datasets. This automation ensures your containers always run at the most cost-effective tier without requiring manual administrative intervention. Let's trace a lifecycle management rule in action using this state diagram. A blob is initially created in the hot tier. The Azure Policy Engine evaluates it daily. After 30 days of no modifications, the rule automatically transitions the blob's state down to the cool tier. If it remains untouched for another 150 days, hitting the 180-day mark, it's automatically moved to the archive tier. Finally, after a full year, a deletion rule triggers, securely removing the blob entirely. This represents automated cost governance, seamlessly managing your container's data. Protecting the data within your containers from accidental deletion or malicious overwriting is critical. Azure provides powerful, native data protection features. First, we have soft delete. When enabled at the account level, deleted blobs or entire containers are not permanently erased immediately. Instead, they transition to a soft deleted state and are retained in the system for a specified retention period, which you can set between 1 and 365 days. During this window, you can seamlessly undelete them. Next, blob versioning automatically maintains previous versions of a blob. Whenever a blob is modified or deleted, a new version ID is created, ensuring you can always revert to a known good state. Finally, you can create manual snapshots, which capture point-in-time, read-only copies of your individual blobs for backup purposes. Together, these features ensure your container data is highly resilient. This sequence diagram illustrates the soft delete safety net in action. A user accidentally sends a delete command for a critical blob in your container. Instead of destroying the data, the Azure Storage Engine intercepts the request, marks the blob as soft deleted, and hides it from standard views. The data is retained safely for the configured period. Within that window, an administrator realizes the mistake, issues an undelete command, and the storage engine instantly restores the blob to its original, active state. For our final deep dive, we will look at object replication. This powerful feature asynchronously copies block blobs from a source container in one storage account to a destination container in another account. Why use this? It is incredibly useful for minimizing latency by distributing data closer to remote users, or for isolating data processing workloads across different Azure regions. To configure object replication, there is a strict constraint. You must first ensure that both blob versioning and the blob change feed are enabled on the source and the destination storage accounts. You then create a replication policy specifying the source and destination container pairs. To optimize your network transfer costs, you can apply prefix filters so that only a specific subset of blobs within the container are replicated. This diagram showcases the object replication architecture. On the left, we have a source container in region A, and on the right, a destination container in region B. Notice the prerequisites attached to both. Blob versioning and the change feed must be enabled for the engine to track modifications. We define a replication rule linking the two containers. Azure asynchronously reads the change feed, applies any prefix filters we define like only copying files in the /logs directory, and securely replicates the block blobs across regions, ensuring our container data is distributed exactly where we need it.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.